afternoon. Hi, how are you doing? Today, without wasting our time, the topic we have today, we want to look at electrolysis. Electrolysis. Today, the lesson objectives are one, by the end of this lesson, you will be able to one, find electrolysis. Two, find some terms used in electrolysis. Three, describe an electrolytic process. Electrolytic process. So by the time we are done with this lesson, you'll be able to define what an electrolysis is. You'll be able to define some terms that we use in electrolysis. Three, you'll be able to describe the process of electrolysis. Now I'm going to start straight away without much ado. And remember when you are taught in your grade 10, you are taught mixture and compound. Taught mixture and compound. And can you give me one or two differences between a mixture and a compound? Yes?
Mixtures can only be separated by physical methods.
Mixture can be separated by physical method. Mixture. Compound. Yes, can be separated by what? Physical method. Yes, what of compound?
It can only be separated by chemical methods.
Physical method. Compound can be separated by
chemical method.
Separated by
Chemical methods.
Chemical method. What are other differences?
Compounds are represented by symbols.
Compound can be represented by chemical formula. Mixture cannot be represented by chemical formula. But compound can be represented by chemical formula, and so on and so forth. So we have many 4 to 5 differences. Compounds can be separated by physical method. Mixture can be separated by chemical method. So when we have a mixture of sand and water, we can use filtration method to separate them. We have sand plus water. We use filtration to separate them into what? Into residue, and what? And filtrate. So this is a physical method. How about when we have a compound? Have you ever thought about how to separate a compound? Can you give me an example of a compound?
Sodium chloride.
Sodium chloride is a compound.
Electrolysis is electric.
Sodium chloride is a compound. NaCl is a compound. Have you ever thought about how to separate these? We'll use chemical method to separate them. An example of chemical method we're going to use is electrolysis. Electrolysis is a chemical method. Other chemical methods are We have ion exchange, resin, ion exchange resin method. All these are and host of others. But for the sake of this class, we'll not go beyond electrolysis. So electrolysis is a chemical method of separation. What we just do, we just use this method to separate this into sodium ion, and what? And chloride ion. That is just what we do in electrolysis. So how can we now define electrolysis? So electrolysis is a chemical process through which chemical reaction is caused to happen within a chemical compound or substance by what? By the passage of electric current into what? Into the molten form of the electrolyte or the solution of the substance if it is salt. So electrolysis can be defined. Electrolysis can be defined as a chemical process used to cause chemical reaction to happen in a chemical substance by allowing electric current to pass through the solution of the compound or its molten form Full stop. So when we're talking about electrolysis, this is what we mean. Chemical process that is used to cause chemical reaction to happen within a substance by causing electric current to pass through the solution of the substance or the molten form of the substance. What do we mean by the solution? What do we mean by molten form? We need to explain all these so that we can understand now. What we are saying when we are talking about solution, we are talking about molten form. We mean now when we have sodium chloride, our table salt, normal table salt is sodium chloride. It's a solid. When we dissolve it in water, when we add water to it, it will become salt water. We call it sodium chloride solution, aqueous. This is sodium chloride solution. So this is what we are going to put into a container, sodium chloride or salt water, and we put two wires and we connect it to electrical source, and we allow it to happen. So this is an electrolytic process. Or if we don't want to use that, we can also use molten form of sodium chloride. Now, sodium chloride can be melted if you heat it to a temperature of about 801 degrees C. It's going to become liquid salt, NaCl liquid. But that temperature is very high. You have to heat it to that temperature before it becomes this liquid. And when this happens, we can also use this, and we put it in our container. This molten form. Let me use ... molten. We connect it to our electrical source, and it gives us what? It still gives us the product. It still separates the compound. So this is what we do in electricity. So that means electricity involves a liquid, external source of power, and conductors. Three things that are very important. There is a liquid, there are conductors like wires, then there is external source of power that that will drive the reaction. Is that clear? Do you understand that? Okay, now let's proceed. Let's look at some terms that we use in electrolysis. Look at some terms that we use in the electrolysis. I'm going to talk about the first one. The first term that we're going to talk about is electrolyte. Electrolyte. What are called electrolytes? Electrolytes are the liquid conductors. They are the what? They are the liquid conductor. The liquid conductor that allows liquid conductors that allow electric current to pass through them. So electrolytes, they are liquid conductors. They are substances that can allow passage of electric current. Example of that are solution of salt, as I've said the other time. For examples, you have salt solution, acid, dilute acid. All these are examples of electrolytes. Why they will allow electricity to pass through them. So these are what we put in our electrolytic cell. So here we're going to have electrolyte. Here we're going to have electrolyte. So we can what? Solution of the salt, solution of an acid, can be molten form of the salt. So any of these three can be electrolyte. Now, non-electrolyte are the liquids that do not allow electricity to pass through them. Non-electrolyte are what? Are the liquids that do not allow electric current to pass through them. So we call them liquid insulators. They are also called liquid insulators. Electricity cannot pass through them. So example in this aspect include majority of our organic compounds. All organic compounds like kerosene, petrol. Examples include kerosene, petrol, glycol, petrol, we can have diesel,
Benzene.
we can have benzene, toluene, and so on and so forth. Majority of these organic compounds are non-electrolytes. Why? Because they don't contain charged particles. We will talk about that shortly. But electrolytes contain charged particles, and that is the reason why they can allow electricity to pass through them. Is that clear? Can I go forward?
Yes.
Okay, now I want to look at another one. We're going to look at electrodes. So when we talk about electrodes, these are electrical conductors in form of wires, in form of plates or rods that allow electricity to pass through in and out of an electrolyte. So electrodes are what? Are metallic conductors in form of wires, rods, electrical current into an electrolyte or electrons out of an electrolyte. So now what? Electrode is the connector between the electrical source and the electrolyte. The electrodes are the connector between the what? They are the connector between the electrical source and the electrolyte. They allow the passage of electric current into the electrolyte, and also they allow the flow of electron from the electrolyte into the external circuit. And they are of two types. They are of two types. They are of two types. Number one, we have the anode and the cathode. Anode and the cathode. Anode is the positive electrode, while cathode is the negative electrode. Anode is the positive electrode, while cathode is the negative electrode. Called anode and ion electrode. Get that electrode, while cathode is cation electrode. Now this anode is the positively charged, while cathode is negatively charged. Anode is positively charged, while cathode is negatively charged. Also, we also have what we call active electrode and inert electrodes. We also have active electrodes and inert electrodes. What are active electrodes? Active electrodes are the electrodes that take part in an electrolytic process. They take part in that chemical reaction. You know, we have active electrodes are involved in an electrolytic process. Electrolytic process. They take part in electrolytic process. Examples are you have copper electrodes. We have platinum electrodes, sodium mercury electrodes, or let me say sodium electrode, and so on. All these are active electrodes. Why? Because they are involved in electrolytic process. The next one is what? Inert electrodes. Inert electrodes are what? Are also called passive electrodes. They don't take place in an electrolytic process. They don't take place in an electrolytic process. We call them inert electrode. Example of that is majorly graphite, which is carbon electrode, is an example of inert electrode. They don't take place during chemical reaction.
Yes, you did hit.
They don't take place during chemical reaction. Another thing we need to look at is what is called spontaneous reaction and non-spontaneous reaction. Electrolysis is a non-spontaneous reaction. Why do I call it non-spontaneous reaction? It's a reaction that cannot occur on its own. It cannot occur on its own until an electrical source from the outside of the setup is allowed to come in. So, for reaction to occur within the substance, that is electrolyte, For the reaction to occur, there must be supply of energy from the outside. And so, such is referred to as non-spontaneous. It does not have the energy. Energy must be supplied in form of electric current into the electrolyte for for the electrolytic process to happen. So in other words, the supplied energy is used to drive the entire process of the process. So we can say electrolysis is a non-spontaneous reaction. Why? Because energy is supplied from the outside